Good morning, everyone. Welcome. I'm Cindy Sesegoy, the Executive Director of the Cleveland 2030 District. It's our pleasure to put on these education sessions. Thanks very much to our event sponsors today, Geithner Consulting, one of our longtime professional partners, Citywide Maintenance of Cleveland. They're a new professional partner to the Cleveland 2030 District and one of our long-standing member properties, Cuyahoga County. As you know, we do about 7 of these sessions every year. Today our session is Lighting A to Z. I know that you'll enjoy today's session. I've seen the slides, and I'm sure you will not be disappointed. We've got some great speakers to really cover everything that you'd ever want to know about lighting. As you can see, this is the second to the last session for the year in November. We've listed water conservation projects, although I think that's going to, that topic will be broader, and we're going to talk about water quality since that's top of mind with COVID and pandemic issues. All the sessions are recorded and posted to our website under the district library. Our speakers did give permission for us to record and post both the slides and the recorded session. So give us a few days to get that on our website, and you can always go back and review it at that time. I would like to thank COSE, again, one of our longtime partners, supporters of the Cleveland 2030 District. They're our partner for today's session. They helped us organize and reach out to speakers and put this session together. So Nicole and Andrew, thanks very much. Today's speakers, we have Ron Saunders, co-owner of Fresh Air UV, Joe Stoner with Lighting Services, Jim Porak, and Chris Johnston with Energy Focus. And just before we start, a couple of more housekeeping items. After today's session, you will get a really very short 1-question survey. Just tell us how we did. And there's a space for comments if you'd like to make any comments about today's session or future sessions. We really need your feedback. Also, at the end of September, you will be getting a survey asking you what you want to hear for our 2021 sessions. Not sure how many of them will be in person and how many will be webinars, but we do really want to hear from you in terms of what you think we should present to you next year. Also, the education credit sign-in sheet will also be sent at the end of the session. And with that, we're going to get started here. If you have questions, you can post them in the chat box, and Isabella McKnight, our program manager, will be monitoring those, and we'll take questions at the end of each speaker session. We'll start with Ron Saunders. Mr. Saunders received his BSME degree from Drexel University in Philadelphia. He worked performing toxicology, microbiological and chemical identification at Toxicon and VOC Analytical, both environmental laboratories. Ron was the Southeast U.S. sales manager and managed sales of analytical services to municipalities and consulting engineering firms. In 2002, Ron became the co-owner of Fresh Air UV, a manufacturer of indoor air quality products since 1988, providing solutions for institutional, healthcare, commercial, and industrial sectors. Mr. Saunders is a recognized speaker for the Refrigeration Services Engineering Society, Air Conditioning Contractors of America, Association of Physical Plant Administrators, National Air Duct Cleaners Association, and Refrigeration and Air Conditioning Institute of Canada. Ron is a 16-year member of Heating, Air Conditioning, Refrigeration Distributors International and a 5-year board member of Cystic Fibrosis Palm Beach chapter. Ron, thanks so much for speaking today.
Oh, you're welcome, Cindy. Happy to be in front of your group. I really appreciate everybody's time. I'm the lighting guy that inactivates COVID and kills other bugs. So I'm not the physical lighting guy. You'll hear from more of those guys later, and a great group of men coming on after myself. So appreciate the opportunity to educate everybody on ultraviolet germicidal light. So Fresh Air UV has been involved in UV and carbon technologies for surface and airstream disinfection since 2002. I wanted to provide everyone with a coronavirus update. I'm going to go through the next slide and give you some bullets, but if you go to our website, you'll see exactly what how we present our products as it relates to COVID. But Fresh Air UV systems and all UV systems, not just mine, have been tested and validated against bacteria, viruses, mold, and fungus, and can achieve up to a log5 reduction when sized properly. So, and that's the factors that need to be addressed when you talk about UVC, is how much UVC do I need depending on air velocity, size of the space, as well as the biological target. We're very lucky when it comes to SARS-CoV-2 that it requires a very low dosage of UVC. So it's actually very easy for ultraviolet lights to inactivate COVID, again, depending on the time in front of the biological target. So our products are applied in either the coil and drain pan area or in the supply plenum. Because COVID is such a low dosage of UVC required, we're actually applying it more at the coil and drain pan because it may be unnecessary to have those extra lights in the ductwork. So it all depends on your application. But for most people, we're recommending keeping the lights at the coil and drain pan and inactivating COVID at the same time as keeping that area disinfected. The product that we feature on most of our applications is in the center picture. It is simply a ballast and a lamp, not very much different than a fluorescent light fixture, except that we use a different ballast and a design so that it's waterproof, and we use a germicidal light instead of a visible spectrum light. It's not coated with phosphorus on the inside, otherwise you would get visible light as opposed to germicidal coming out of these lamps. The picture on the right shows that you can apply UV lights into PTACs, into fan coils, just about everything. And these are just some of our customers. A lot of these have really ramped up opportunities this year with COVID, specifically cruise ships and hotels and even buses. Anywhere where you've got inhabitants contained in a very small space, they're all wanting to apply UV lights into the air conditioning systems. And UVC is not new. It's been validated by just about every major organization when it comes to air conditioning, U.S. Green Building Council, well building, U.S. General Services Administration, and the CDC. Here's a filtration disinfection resources guide from ASHRAE, and they absolutely recommend banks of UVC light installed inside HVAC systems or associated ductwork. And this is their infectious diseases position document that just came out a few months ago. And again, they're definitely recommending ultraviolet germicidal irradiation, or UVC as it's called, in addition to other supplemental filtration. About a month ago, the Tennessee Valley Authority announced incentives to schools and businesses that installed UV light to allow kids and adults to get back to their schools and businesses, and offered a $30 a ton incentive for that to happen. So this is the largest power utility company in North America, and they're incentivizing companies to install UV. So when we talk about indoor air quality, which is what we used to talk about before COVID, we were trying to control these three contaminants that causes asthma allergy related illnesses per the Center for Disease Control. And particulates is one entity, volatile organic compounds or odors, and then also mold and germs. The reason we have indoor air quality problems is because we're making our buildings more efficient, which actually traps in a lot of chemicals and biologicals and just recirculates the air. You know, the HVAC system is the lungs of our building, and if we don't take care of it, it will become unhealthy for the entire facility. So filtration is excellent, and again, it's one of the three components of proper indoor air quality. But unfortunately, for biologicals and chemicals, it's about as efficient as a tennis racket for those microbiologicals and chemicals. So we do complement filtration. Filtration is all about trapping particulates. And then there's other opportunities to remove the other contaminants with other technologies, one of them being UV. So when we talk about microbials, UVC light is recommended for removal. For gases, activated carbon or some type of photocatalytic oxidation that doesn't produce ozone. And then for particulates, of course, filtration. So HEPA is our best friend. Unfortunately, it can't be used in line in most systems, so it's a kidney loop. So we do as good of a filtration job as we can and still not hurt airflow. So MERV 13, MERV 14 has been given a lot of guidance throughout ASHRAE and the rest of the AC industry. So this is the wavelength of light that I'm creating in the glass of the lamp. It is ultraviolet germicidal or UVC. It's just beyond the visible light spectrum of the rainbow. We're not actually generating any heat, microwaves, radio waves. We're on the ultraviolet spectrum. The first one you have is UVA, which a lot of us know as black light. UVB, which gives us a suntan or a sunburn. And then UVC, which is actually germicidal. UVC light doesn't produce ozone unless you want it to. You can create a 187 nanometer spectrum that will produce ozone. UVGI or UVC, UVC is the spectrum. UVGI stands for ultraviolet germicidal irradiation. That's taking that spectrum, the germicidal spectrum, and irradiating a specific target. Was discovered in the early 1800s. It's been used in water and wastewater treatment predominantly since the 1950s and still is today. And in the 1990s, we started to utilize it in HVAC applications. And over the last 10 years, hospitals have really embraced UV to help to control their hospital-acquired infections like MRSA, VRE, and C. diff. How it works is it basically scrambles the DNA of microorganisms, not allowing them to reproduce, effectively killing them. So it's basically scrambling DNA. Again, we won't kill every organism, but we will inactivate it or render it unable to reproduce. So for surface disinfection with UV, you've got an unlimited amount of time, and we've been using that application of coil and drain pan irradiation for many years to keep those areas completely sterilized. Now with COVID, people are all asking for airstream or airborne disinfection. And normally that is very difficult because a lot of bugs require a lot of energy. We're very lucky that COVID requires a very low dosage of energy. So we can actually use a blue calc sizing software and create an array of UV that is actually cost effective, while also keeping your coil and drain pan clean for energy benefits. So this is a chart. You can find this anywhere on the web. It's a dosage of ultraviolet C for complete destruction of microbials, or a kill rate or intensity. And you can see that some of those numbers are 4 digits, some are 5, some are 6. Actually, COVID is about the lowest number on that list. It only requires 3,700 microwatts per second per centimeter squared. You may hear that as millijoules as well, or microjoules. But it's a very low dosage of UVC. If we were trying to kill mold spores in flyby kill or airstream kill, we may require 100 times more energy than COVID. So because it's such a low dosage, UV is definitely the highest recommended product to inactivate COVID right now within ASHRAE. So we used to sell and market UVC lights to keep coils and drain pans clean, and also providing some indoor air quality. So we used very low dosage of UV on coils and drain pans. So you can see the picture is very common in the industry. If anyone ever replaces a UV light and they're asked, how does the coil look? Everyone says the same thing, it looks brand new. So UVC lights, by not allowing anything to survive, any biofilm, it doesn't insulate the coils, it doesn't impact the coils, it keeps them 99.9% disinfected. This also helps with the dirty sock syndrome that occurs in parts of our country. This is true of all UVC lights, pre and post. You can see the log reduction of microbials. Now this picture actually shows UVC light cleaning a dirty coil. We actually don't recommend that. We want you to start clean and stay clean. So we ask our friends to clean the coil first and then apply UV, and then you absolutely will not clean that coil again, as long as you have good filtration as well. But it's a very low cost solution to eliminate bacteria, viruses, and mold in this cold, dark, wet place. And because it reduces coil cleanings, you won't be paying as much in maintenance every year to keep your coil clean. And again, because it keeps the biofilm off the coils, you actually get much improved efficiency. So anyone that monitors their equipment should absolutely put UVC lights in, and you'll see that actually the return on investment is as little as 1 year. So the two pictures on the left are the most popular applications of ultraviolet light, right up against the coil and drain pan. But we do have makeup, air, and exhaust disinfection that does include ozone, if that's your preference, and we would recommend that for exhaust air. We also make wall sconce mounted UVC lights that irradiate a room or occupied space that is unoccupied when the UVC lights are energized. UVC lights are not complicated. Again, it is very similar to a fluorescent light fixture. We just build up everything inside so it runs in this cold, dark, wet place. And that's an example of the power supply. You can see these are applications installing UVC lights. And this is our most popular product, as I showed you on the earlier slides. It simply takes a UVC light of 18, 24, 32, 46, or 60-inch lengths, and we build a rack system so that you can simply snap the lights onto the half-inch conduit that's secured on the ends and also through the other framework. So it's simply mounting a framework so we can attach these very light UVC lights to it so that you get the maximum amount of irradiation inside of that area. Sizing the systems is actually really easy, but we can help you do it. But we're simply spacing the lights out to a certain dimension so that we can get maximum radiation into the coil itself. Again, these are all based on coil irradiation and irradiating a specific surface, but usually with just the lights that we size for surface, it's actually provides a log 2, log 3 reduction of COVID at the same time. Again, because it's such a low dosage of UV. Sometimes customers will want to add another row of lights into it, so they maximum, again, add more irradiance to the system. And we don't necessarily recommend it, but some customers do request it. And sizing these systems is very simple with our product. You just have coil height and coil width, and that determines what system we'd recommend. You can see here that if you have a very large coil, 72 inch by 72 inch, all that's required is 2 60-inch lamps. So that's 2-year 60-inch D for dual. So we have two 60-inch lamps replaced every other year. So it's a very low cost system and very low maintenance. If COVID required more disinfection, if it was one of those mold spores or a bacteria that required more dosage of UV, then we would absolutely recommend Airstream disinfection. But for most customers, we're not recommending this. It's overkill. And to size the systems, great to go through our website, go through our Blue Calc questions, and you'll get some really nice printouts with more information on COVID inactivation. So this actually tells a lot, and I'm happy to provide, again, Blue Calc for anyone's applications. This basically shows us on the left the ideal system configuration, and it's very difficult to see, but in just a couple of minutes we will kill even the hardest to sterilize mold spore on the coil face, and it does stay there 24/7 so that as new microbials come and collect on that cold, dark, wet place, we will irradiate it and sterilize it. The one on the right, Blue Calc, is actually showing those same 4 lamps that we're using on the left in 11,000 cubic feet per minute airflow and a log 3 COVID inactivation in a single pass. And you'll see that I'm actually not going to recommend Airstream for most of your applications, just keeping the surface irradiation. Besides larger air handlers, PTACs, fan coils, small rooftop units, we make a variety of different products, including this series in front of you, which features, again, our lifetime power supply. And then this one has 2, but some have up to 4 lamps on one power supply. Those are 15-inch lamps. They're a 2-year operation. And then the PTAC and fan coils have become more popular since COVID. The PTACs especially. It uses just a silver dollar size magnet to contain the lamp within the PTAC. And now
Ron,
I'm happy to answer any questions for anybody.
Yeah, Ron, thanks so very much. That was a wonderful presentation. Isabella is manning the chat, and if you have any questions for Ron, You can type those into the chat right now, and Isabella will read through them.
So I have one question so far. In walk-in coolers and freezers, does the system keep food fresher longer?
Very good question. UVC lights actually don't provide any output at temperatures below freezing. So if we get below freezing, we don't have enough UV. The product that has been featured over many years in that application to keep food fresher has been ozone generators. And those are still recommended for food storage. Again, it requires a specific amount of dosage of ozone to render microbiologicals useless, but sometimes you can have too much ozone and you'll take the smell and flavors out of produce and other foodstuffs. So you do have to be very careful when you're using ozone, but that would be the recommended method, not UV.
All right, next. Ron, apologies if I missed it. I'm curious the energy use requirements for this technology. What wattage ranges are the lights and how many hours a year do they operate?
So the lights themselves are they operate at a very low amperage. At 220 volt, you're looking at about a half an amp per lamp. So if you have that 72 inch by 72 inch coil and you've got two lights in there, you're looking at about an amp of energy required. So they're very, very low. They use a solid state electronic ballast. So it's a very, very low amp draw and it's efficient as possible. The lamps themselves don't require any attention for 2 years until they're recommended to be replaced. So there's really nothing to do. You can buy soft quartz lamps from other countries. We elect not to do that. Those products require you to go in every 3 months and wipe the glass so that you don't have any collection of particulate or humidity. We use a hard quartz design lamp built here in the US by a couple of different manufacturers. And those are not susceptible to humidity, grease on your fingers, or particulate. So nothing to do with the lights except every 2 year replace them.
What is the risk of direct exposure of UV to humans?
So again, UVC light inactivates every virus, kills every bacteria, it kills every mold spore. We are just a big living organism. So UVC lights are dangerous to humans as well as all microbials. You don't need a very long exposure to feel like you've got sand in your eyes about 8 hours later. It's actually the same as a welder's flash burn. So we do recommend people use protective eyewear and also protective clothing if they're irradiated by UV, which we definitely don't recommend. So for most applications, we'll provide a door interlock switch on the air handler door so that if people do open it to service the lights or the inside of the air conditioning system, that the lights do go off. So there's no lingering UVC energy. If it's on, it's on, and you don't want to be exposed for more than about 5 seconds. Otherwise, again, you'll have that welder's flash style burn. And if you're exposed to longer amounts of UVC, you'll actually get a really bad sunburn. So we definitely recommend people are trained appropriately on this product and take the proper safety precautions.
One more question. Someone said, apologies if I missed the cost implications. I think they're wondering the cost implications of the technology.
Yeah, so for that 72 by 72 inch coil, you're looking at between about $1,100 and $1,500 even with installation for the first 2 years. And then you're looking at after just replacing lamps, you're looking at about another $400 or $500 in total lamps for that 72 by 72 coil. So, but if you consider the cost of cleaning the coil every year or twice a year as recommended. And then adding all of your coil cleaners, your drain pan tablets, and then just looking at the equipment itself. If it does develop some biofilm, it reduces efficiency. So, over the life of these products, if you do the proper cost analysis, you'll see that the ROI can be as little as 1 year, depending on your coil.
All right. Those are all the questions I have in the chat. If anyone wants to send another one in really quickly, we could try to cover it. Looks like that's it.
Great.
Okay. Ron, again, thanks so very much for a wonderful presentation. We appreciate your being here today. We'll move to our next speaker, Joe Stoner, with Lighting Services. Mr. Stoner lives in the Akron area and has been in the lighting industry since 2002. He's had a variety of roles, including inside sales, project management, and design engineer. Currently, his main focus is building relationships with the ESCO community and commercial industrial markets to develop energy efficiency projects that utilize the latest lighting technology. Joe has attained the certifications of Certified Lighting Management Consultant and Certified Lighting Energy Professional through recognized industry organizations. Joe, welcome, and thanks so much for presenting today.
Thank you, Cindy. Thanks for having me. Can you hear me okay?
Yep.
Great. Ron, that was a great presentation, and your credentials are much more impressive than mine, but thanks for reading the bio, Cindy. Can move to the next slide if you wouldn't mind. Thank you. Today, again, as Cindy said, I'm Joe Stoner with Lighting Services. Been doing this for a long time, and most of you probably know a lot about lighting. It's not new. LED's now been around for a long time, but I thought I'd give a brief overview of lighting technology, sort of as it ties into controls, and then give some examples of exterior and interior controls, obviously, as you can see, from basic to kind of the networked and on up into the more intelligent lighting systems. And keep in mind, I think all of these lighting technologies can be controlled in some way, shape, or form. I've highlighted some that are obviously more, for lack of a better term, more controllable than others. But I'll start with the more, say, simple technologies that are typically the least expensive, and then move up to, say, the more complex. This is just a standard LED tube. You've all probably seen this in some way or form in your facilities, but it operates off of either a existing electronic ballast, line voltage, or an externally tied together system, which would be an LED driver. We find the most popular is that center one there, the UL Type B, which is line voltage. Most people want to get the ballast out of their facilities, but if that's a concern, UL Type C would probably be your next best option. I will say too, as I mentioned, all of these different technologies or types of LEDs are controllable. You'll hear from Energy Focus here in a bit, and they have some of the Type B tubes that are controllable, dimmable, and I don't want to steal their thunder, but they do, as I presented this as sort of a low cost, inexpensive process of replacing fluorescent with LED. It's very functional too. This would be sort of a step up in terms of controllability. This is a LED board and driver kit that you can put in an existing fixture. One of the nice things about this is it's not limited to where you'd have just a standard fluorescent tube. You can put these in just about any fixture or stick them to a wall and a wrap, a fixture that doesn't have a housing. So just a little bit different take on putting LED into an existing fixture. This may be the most popular at this point in time when it comes to specifically commercial office space. A lens door or door frame kit is something that you don't require the actual removal of the fixture, so there's no work above the plenum. These kits, what you see there on the right is basically the brand new lens door that would replace either a parabolic lens in a recessed trough or a flat prismatic lens. And then if you see the picture at the bottom, that's the housing that would then fit into. And one of the nice things about this, as you'll see down below, you can tie this into network controls with an integral occupancy sensor or smart sensor. And that picture of the 2x2 volumetric kit there shows a small integral sensor that's really not noticeable, but will, again, as we get into the controls part, make a little bit more sense. Of course, new fixtures. This is probably the no-brainer, right? Obviously, if you want to get LED into a facility, whether it's new or an existing built facility, replacing a fixture makes a lot of sense. It's just a little bit more cumbersome in terms of labor, and the fixtures tend to be a little bit more expensive depending on the style than, say, a door frame kit, but that's almost a moot point now. They've come down in cost quite a bit. And again, can tie into network controls is really the purpose of showing this option. I put this up just as a FYI. It's something we see a lot of folks do because it's inexpensive and it does save energy. What it doesn't do is light the space that it's designed to light. It doesn't really have any controllability. We steer clear of these, but I just wanted you to see it. There are a few applications for these, such as a post-top fixture, a decorative fixture. It has its place. We limit them as best we can into our projects. Exterior fixtures is somewhere I'd say we'd almost always recommend a replacement of the fixture itself. They're, going back to that corncob picture we just showed you, that's where you'll see a lot of these floodlights or area lights or wall packs with one of those shoved in, and you just kind of see a general blob of light, below the fixture, or it's just not doing the job that the fixture that was created for a high intensity discharge lamp to do. It doesn't have the oomph, the punch. There's not enough lumens coming out of those lamps. So we would recommend almost always to replace an exterior fixture. As you can see some of the advantages here, I'd say the most important, in my opinion, or I say there's three things. One would be optics, actually getting the light where you need it. That's not only for just plain energy efficiency, but for safety. The also lifespan, these things last, say 100,000 hours or more, whereas the corncob style or any type of real retrofit product has, say, roughly half the life at best, typically. The other reason these are nice is you can tie them into network controls. That's probably, in my opinion, those are probably the most important reasons, although there are others. And then again, the efficiency of these fixtures is significantly higher, so the energy savings is better as well. Since we ended on new exterior fixtures, we'll talk about controls a little bit as it relates to exterior lighting. And most of you are probably familiar with either a time clock or a photocell, standard photocell. At dusk to dawn, turns the lights on when it starts getting dark, turns the lights back off in the morning. At dawn, there are other ways to control, simply control. This is the basic type, but part night control would be basically a pre-programmed photocell. So all these photocells are going to look relatively similar. They just all do different things. But as opposed to a traditional photocell, a part night control cell would turn the lights on at dusk and then dim them roughly halfway through the night, again, to save more energy. And the nice thing about these, they automatically adjust to seasonal time changes, and that reduces the maintenance of having somebody go in and try to reset a time clock or replace photocells as they go bad or come inoperable. Occupancy control. This is very similar to if you put an occupancy sensor on an exterior fixture. Most of the time they would be built into the actual unit itself. Operate very similar to an interior occupancy control, which may scare some of you because there's, over the course of time, the history of occupancy sensors, people have that image of waving your hands to make sure that it works. We've had very good success with these in our experience, and they save a lot of energy as well as can be a deterrent for any type of say, vandalism or trespassing, as lights when they initially come on, 100% brightness, dim down to a preset level, and you can see the pattern there. As motion is detected, they ramp back up. So typically, say if you have this in a school or a parking lot at a shopping center, it may look dim. People think they can go in and create bad behavior. All of a sudden lights go up, and hopefully that deters them, and also would again increase the view of the cameras and the sensitivity of the cameras in any given space. The next step on exterior controls would be to network these sensors together. Typically, this would use, again, a sensor of this type. Sometimes they're built into the fixture. Most of the time, it's a node that you see in that top corner. Basically, you'd put these wireless nodes on all the exterior fixtures, and when commissioned correctly, these would create a self-healing mesh network that ties all the fixtures together. Each fixture would have its own address, and you can tie in multiple sites to one system for unified control. So if you have multiple campuses for a college or multiple buildings, it can all be tied together and controlled. You can from one location for either maintenance and or safety and security. We're currently installing this type system. That picture is from Collin College down in Texas, where we've recently installed a bunch of these new LED fixtures with this and are in the commissioning process as we speak. But you can adjust light levels, turn fixtures on off from one location or from an app. So failure reporting too is one thing I didn't mention here. And while that may sound silly, you can see which fixtures are out. Most of the time, the maintenance crews aren't walking around at night trying to figure out which lights are out. So this sends an alert to the system and says, hey, fixture in XYZ corner or with this address is out, and can be addressed very quickly. And kind of the cream of the crop with exterior, and I'm not going to spend much time on exterior in general, is smart cities or IoT. And IoT, I'm sure, is a term you've heard a number of times. I've heard it through some of these 2030 presentations, but just a quick definition of that. IoT would be the Internet of Things, and it describes the network of physical objects or things that are embedded with sensors, software, and other technologies for the purpose of connecting and enhancing and exchanging data with other devices and systems over the internet. So what you see in this picture here is a number of different, at the top, street lights connecting through, gateways and to the cloud, taking all the information that's generated from the different sensors that are collecting the data and pushing it up through the cloud into different applications. And it just adds an entire new level of intelligence and capability to a connected lighting system. Some of the examples I would say, and are really the most popular there, you can see traffic monitoring, environmental, parking and safety, and waste management. But I would say this is becoming more and more common with cities trying to maintain not only their lighting network as it relates to, if you have a couple thousand streetlights, trying to pinpoint outages and have them addressed in a timely fashion. But as far as parking goes, cameras will see a car, grab the license plate number, and can bill in that way. From safety standpoint, there are basically microphones on a lot of these sensors that can either detect voice and or gunshot detection and dispatch safety services as needed. We're currently installing this type of lighting system, this connected lighting system, down in Virginia for VDOT. So it's becoming more popular as I think time goes on and people see the value and the cost benefit of using a more intelligent lighting system that does more than just turn lights on and off. So we move on to the interior side of things. What would you do? What are the different strategies? How can you control lighting, and what's the benefit there? Just a few of these. High-end trim is probably the most popular, which is why it's on the top. But interestingly enough, the human eye can barely distinguish a difference between, say, 100% and 80%. But literally setting, it's almost an equal equation. If you save 20%, if you go from 100 to 80, you save 20% in energy costs. It also increases the life of the fixture. You can set schedules to have lights on and off during specific periods of time. And you can tie in different apps depending on, again, the complexity of the system. But HVAC integration is very common. And this is something we've actually been doing for years. We have, a motion control in a classroom or an office. It's got an extra contact on it. It can be tied into the HVAC system to open or close or send a signal back to the mechanical control system to open or close a VAV box to adjust the temperature in a room. Again, some of these strategies, like tying it into the HVAC system, can be done with basic sensors, and others take a more robust connected system. And I've included through this presentation, you'll see a number of different pictures and graphs. These I've pulled from, say, Lutron or Cooper or Enlighted or Acuity, some of the partners that we've worked with that have very high quality and intelligent lighting systems. This slide, again, you've probably all seen most of what's on here, but controlling the lighting and adding functionality to a space doesn't require a fully networked system. You can use a combination of standard occupancy or vacancy sensors. Vacancy is probably more popular now due to code, meaning you actually have to turn it on. It doesn't like a wall switch that would automatically, you walk in, lights turn on. A vacancy sensor, you walk in, turn it on, then it automatically shuts the lights off. And that prevents false offs. It prevents false offs as people would walk by an office or a room. You can still have on-off dimming, scheduling, and all that stuff. But again, these are relatively, low cost, easy, room-by-room strategies that you can implement either yourself or as part of an energy project. Another thing too, the dimming and switching control module, obviously that's a power pack that would tie in with this system. We can create zones. You'll see that bullet point down there to create what we would call an AV row in a classroom. So if you have 12 fixtures in a classroom, 3 of them are over the smart board. Right now, there's only one way to turn lights on and off. You can break apart each fixture, each row of lights, or just the row over the board and turn it on and off, or add dimming capability while there's just a 120 or 277 volt circuit in the room. So adds a lot of functionality to the space. Networked interior controls basically just takes many of the components from the basic system and ties them together building wide through a hub or a gateway. This basically allows for an on-site or remote access through a front-end system, either in a manager's office or a mechanical room or from an app. A lot of folks are gearing towards that now with all the wireless technology, iPads and cell phones that we have today. It, again, provides the same functionality of on-off dimming, scheduling, but also adds the ability to monitor and control the system, either, again, on-site or remotely. Can deliver maintenance reports, energy use, and it can allow the participants to participate in a, or the building owner or management to participate in demand response from the utility company. And again, there is the potential here to add IoT functionality, depending again on which system is chosen and how it's set up. Again, you can integrate into the BAS through BACnet gateway, or again, this is a standalone. This is a Lutron dashboard. It clearly shows the boxes there. It has energy reporting, access to the scheduling, obviously occupancy. Will tell you how many of the occupancy sensors are sensing occupancy at any given time. And on this particular screen, it is showing a load shed is in progress. And that's basically, load shedding would be, again, referred to more commonly as demand response. But it's an event, as I mentioned earlier, in which the utility company will actually pay you to reduce your energy consumption on peak load days for a period of time. And again, that obviously depends on the flexibility of your space. It may just require you dimming the lights, or you may have to raise the temperature of your thermostats or shut down altogether. It just depends again on your flexibility and the agreement that you have with the utility company. But again, very functional and accessible. maps or interactive floor plans. This is just purely a sample, but obviously you can see the lights on, lights off. It gives you full access to all the different spaces, how you have the system zoned. It's a real-time view of what's on or off and gives you the, again, access to those zones to control them. Again, these typically you'd have to have an existing CAD drawing of your building of each floor, but those again can be, if you don't have those, developed as part of the implementation process by your service provider. Getting into the IoT for interior, we obviously talk about all the different kind of basic, and then getting into network controls. This adds again the next level of complexity, such as the smart cities and smart sensors on the outside did. But we'll talk through each one of these topics over the next couple of slides, and I think you'll hopefully have a better understanding of why you would potentially consider using a smart connected lighting system in a say commercial office space. This is a basic diagram. This is from Enlighted, which was purchased by Siemens a couple years ago. A very robust system, but again, it basically diagram shows the various components that can be used in a system. And again, starting from the left, badges and asset tags tied to either people or things, communicate via Bluetooth, moving to the right to the sensors, which the whole point of this presentation is how, connected lighting. So these sensors would all be in fixtures and or mounted in the ceiling next to, say, a can light, which obviously would be very difficult to mount a sensor to. But they send the continuously gathered data to the cloud or an on-site energy manager system that can be analyzed by various programs or applications that then would provide the building owner operator or whoever's using the system information to make educated distance decisions or locate different pieces, parts that again are being tracked by those tags. And then in reverse, obviously, from those apps and systems, you can set the parameters and determine what information you would like and how you'd like it to be laid out. Real-time location system. This is becoming more and more popular, probably more so in a warehouse or manufacturing environment than it would be in, say, a commercial office space. But I'd say this is just a simplified version, but the communication path from the asset tag to either a user device or up to the cloud, and then through the analytical software data, and then the information that spits out would be the data or heat maps and such that we'll get to here shortly. This is just a quick example of say different things that can be tracked, and really there's no limit on this. Anything that you can stick a tag to, including a computer or a forklift or a cart of some sort, anything that you really need to know where it is and what its availability is, you can put it on there. We've seen this a lot in healthcare, like that oxygen tank. It can save a significant amount of time for healthcare workers and really increase productivity based on running around trying to find a wheelchair or a gurney or an oxygen tank. Anything that may be used in a hospital setting is where I think we found this to be most used or implemented more than other spaces in terms of vertical markets. And then the map there is just obviously the dots, sort of like you'll see on a GPS screen as it follows you around and where the item is and where it's been and where it's going. So Ron talked a lot about UV and how it can help combat COVID and many, many other terrible things and keep people safe. This is a blip into the safety side of controls, which again, really wasn't talked about until a few months ago when COVID hit our shores and has changed our lives probably for quite a long time, at least the foreseeable future. And one thing as we talk about tracking, because this relates to intelligent lighting, it does bring up, I'm sure, concerns about, privacy and our own personal information. But basically, I'll just read this quick because some of the manufacturers have been very clear on this, but associating individual names with contact tracing tags is not required, nor is a data collection app on an individual's mobile phone. If desired, the system and process can be configured to send notifications using only depersonalized tag IDs. Additionally, all density and bottleneck pathway data is collected anonymously using motion data collected by the sensors. So again, at some level, obviously these tags would be tied to a specific person, but that's not public information. That's not everybody looking at this screen would see that information. So starting with physical distancing, obviously understanding where people are in relation to one another can help create and maybe more importantly enforce policies related to safety and or just people, depending on what environment this is, from each other. So maybe you'd rethink the layout of a space if you find that people are gathering together too closely, or that cubicles need to be moved, things of that nature. Monitoring cleaning, use the sensor data to either validate or optimize cleaning routines, monitor the actual cleaning crews, make sure that they're not missing anything. While cleaning an office space was important before, the disinfecting portion of it has obviously become probably more important than dust and dirt and debris. So again, this could then pinpoint areas with high traffic and high density that could need deep cleaning. Digital contract tracing, this is what I was referring to in terms of the privacy disclaimer earlier, but it can help identify those who may have come in contact with others who have tested positive for COVID, allowing for fast response and obviously mitigating a larger spread. So someone goes home, not feeling well, calls in the office, said, hey, not feeling good. You could get an idea of how many people came in contact with that person and eliminate, or at least try to mitigate the effects of that. Occupancy limits, basically you can have real-time alerts for overcapacity or overcrowding, and again, adjustments can be made immediately. Points of contact, data, this would be data that provides an understanding of how often certain points are being touched and used by different people, and potentially give folks, if the copy machine's being used by 30 different people on a consistent basis every hour, that's somewhere you probably need to monitor and or have some type of disinfectant or policy for cleaning that on a more regular basis. Touchless entry, that's relatively self-explanatory. Badged access to doors with automatic openers would probably be the way we'd see that. And then you can go to the next slide if you would. So we'll see larger examples of these specific maps as it relates to space utilization, which is another strategy or benefit of using this. But these maps specifically are the visualization of the data that's been collected by the sensors on the few things we just discussed, and clearly show areas of concern, which would give building owners opportunity to adjust either paths of travel, or you go to the grocery store now and you can only go one way in an aisle, things like that. I mean, that's the information that this would then provide, so that decisions can be made to mitigate harm. Space utilization. This is really what obviously before COVID was the last few slides we talked about are just a byproduct of the ability of the system to track people and things like that. But it was originally intended for space utilization. If I could get that out without slurring them together. But this picture here is a dashboard, and it basically shows a map of all the locations of each sensor. Since they're integrated into the light fixture, they're obviously all over the place. They're densely packed and really provide full coverage of the space, which is obviously helpful if you're trying to determine different areas of concern. There's no dead spots, if they're connected to the lighting fixtures, because the entire space needs to be lit. The sensors would collect occupancy data And tracking algorithms monitor the patterns of motion caused by people either walking or staying still. And the application analyzes and reports on the space occupancy and movement over a specific period of time. Data, then you take that data, would be displayed in dashboards or charts, as we'll see again below. Cindy, you can go to the next slide if you don't mind. And is then generated into a visualization such as this, again, where it shows the hot spots. And this is a heat map. It's a larger version of the one we just saw. So a lot of overlap here between the use for this on the safety side for COVID and the space utilization. But the heat map shows basically the aggregation of occupancy measurements over a given period of time. So in general, where are people spending the majority of their time? Are they in one spot? Are they spread out evenly? Do we have too much space? Do we not have enough space? Again, this information can help management evaluate the overall need for office space in general. Motion trails, while similar to heat maps, the difference would be this is the aggregation of, instead of the aggregation, I'm sorry, of the occupancy over time. The data basically shows how people move through a space over time. And this helps managers understand where people would be traveling to and gives them data to make changes in the flow of traffic or where spots of congestion occur. Maybe the sales team should move closer to the marketing department. Maybe they need another copy machine in the northwest side of the office. The less time people spend up and about, either looking for things or just randomly moving about, obviously the more productive they are. The last two slides, I'll just touch on energy management. Obviously, energy is a huge part of our business. We are literally in the business of saving energy. Lighting is just how we do that. But these two slides, again, cover energy management. And in many systems, the system gathers data on usage, actual usage of the light fixtures, light levels, and temperature. And equipment can be added and adjustments can be made, such as we talked about high-end trim. Again, if you can barely distinguish the difference between 100% and 80%, why would you not turn those lights down immediately to, one, save energy, and two, increase the life of the fixture itself? And honestly, over the last few decades, we've changed as human beings from more, I shouldn't say few decades now, we've been using computers for a long time, more than a few decades, but I'd say more than not, that's the time period where we've seen people shift from more paper-based functions to more computer-based functions. And we walk through office spaces all the times where either lamps have been removed by individuals above their desk, or as a group by maintenance, just to reduce light levels because people feel that those spaces are overlit. Daylight harvesting would be another option. Those can be, again, either a standalone sensor or tied into a fully networked system like this. It can be tricky. Those can sometimes be a fickle type of sensor, but if implemented correctly, will automatically dim lights to a predetermined light level based on available daylight. And really the goal is the occupants don't know that that's happening. Occupancy sensors, that one again is relatively self-explanatory. We've talked about it already. They've been around for years. They used to, as I mentioned, be somewhat fickle, and sometimes still are. It just depends on what obstructions are in the way. But they used to be all passive infrared, so that was the only technology we had. Over the last decade or so, they've gotten significantly better, and most have dual tech, which adds ultrasonic, which is, once the sensor itself has been turned on by infrared, ultrasonic or sound, a microphone will keep that on so that you don't lose the or have a false off and upset people or have an accident. Task tuning, again, you can set through this system, you can set certain lights to be on, off at a certain light level, either over a specific area. I mean, down as granular as one light fixture to, again, the zones or groups of light fixtures. And then tunable white or human centric. This is something that I can't say it's new, but it really hasn't been very popular because, again, the cost of it has been prohibitive. But not only in fixtures, but again, tubes, as I'm sure you'll hear from Energy Focus, it's gotten relatively affordable as well as simple to install. So this basically, tunable white takes lighting in an existing fixture from 27K roughly up to say 6,000K or so, which would be from the warmer spectrum of light up to the cooler, more daylight associated spectrum of light. And honestly, people feel and respond differently under those different tones. Warm hued light typically promotes a feeling of calm, while cool white light increase alertness. As it relates to energy and a connected lighting system and a dashboard, this is my last slide with anything educational, but basically this is an example of an energy intensity map. Obviously the darker areas would show where energy is being consumed more heavily. You can see around the perimeter, we could maybe make some assumptions that there's daylight sensors there, that there's daylight coming into space, and certain fixtures have dimmed down. And again, the interior of the space is always going to be lit more brightly than the exterior as long as there's windows there, so that would make sense. But this is just an example from Enlighted, again, one of the many manufacturers that make these systems of information that you can take and digest to make decisions about your facility. But all in all, as a quick just wrap up, there are many options when it comes to LED technology and getting it into a space. And then obviously determining if controls make sense and what level's right for your specific space. Lots of professionals like us out there, more than happy to help. But appreciate your time and more than happy to answer any questions.
Thank you so much, Joe. I do have one question in the chat so far. What would be suggestions for best lighting practices for cubicles? Also, any suggestions for lighting in windowless offices? We're enclosing some areas due to COVID and turning them into offices, and I'd love to try and make these offices better for the occupants. Thanks.
Very good. That's a great question. And I would say, as we talked about almost the very last portion of this, that human-centric lighting, again, adding that in is relatively inexpensive at this point. So taking those fixtures and either putting a door frame kit or some type of tubular product that is, you can shift the color of light, will give the occupants in that space the opportunity to change the color temp themselves, depending on how they're feeling, their mood, maybe mimic, what their peers are seeing in terms of the daylight coming in the building. Yes, Cindy, is that you?
Cindy? We could hear you.
So I'm not sure if that answered the question, but I believe that would probably be, if you're going to have interior offices that don't have access to daylight, putting some type of color tuning in there would probably be the best way to mitigate the difference between outside and inside.
All right, another question. How open/compatible truly are these systems with BAS systems?
That's another good question. And again, that's why there's so many different options when it comes to this. Some are very proprietary, others are very open, some integrate better than others. It would purely just depend on what the specific BAS system is. Almost all of them communicate with BACnet. It's just a matter of what dashboards you can tie in and what they look like, depending on, again, what the existing system that operates the facility is. I know the Cooper or Eaton, whatever you call them these days, wavelength system that we're putting in down in Texas, they're keeping that off the BAS. They've actually separated the two because they wanted a separate standalone control system for their exterior lighting. So those dashboards then would look similar to what they did on that first slide. You'd have access to those. As you tie them into a BAS through BACnet, that obviously changes, and they'd all be different. So almost all of them will connect. It's just a matter of the functionality, and I couldn't give you a specific without more specific, information on the existing and or the system chosen in the interaction between the two.
Awesome. Those are all the questions I have. I think we're going to move on to the next speaker, and then if we have more, we can circle back at the end because we are running a little low on time.
Excellent. Thank you.
Mm-hmm.
Thanks, Joe. Can you guys hear me now?
We can hear you, Cindy.
Okay, sorry, I had some kind of audio trouble on my end there for a minute. Joe, thanks so much. That was a really great presentation. We appreciate it. We'll move on to our next two speakers. Chris Johnston, Director of Total Sustainability at Energy Focus. Having completed his degree within the University of St. Andrews in the UK, Sustainable Development Program, Chris also wrote and produced an award-winning environmental documentary and received the EPA's President's Environmental Youth Award in 2012. With the Energy Focus team, Chris is working to reduce the life cycle impacts of lighting projects while maximizing the health benefits. He's based in the New York City metro market. Jim Porak, Business Development Manager, Channel Partners and RSM team at Energy Focus. Born and raised in Cleveland, Ohio, and a graduate of The Ohio State University with a degree in mechanical engineering. Jim has 27 years experience in thermodynamics engineering with a special focus on energy savings projects and new energy savings product development. Together with Energy Focus, Jim is working on innovations in LED lighting control systems, industrial LED retrofit projects, and UV disinfection lighting technology for both residential and commercial applications. Jim and Chris, welcome, and thanks so very much for being with us today.
Thanks, Cindy, for that introduction. And thanks, Joe, for that great introduction to LED lighting. Helps a lot for giving context to what we're going to be talking about. So we can get to the next slide. So just sort of why you should, why we're capable of talking about what we are. So Energy Focus started in 1985 as a fiber optic lighting company focusing on safety in like pool environments. And then we transitioned over to LED right around 2000 when we got a military contract through DARPA to produce LEDs for the US Navy. At the time, there really were no lights that the Navy could be using that they could put on their ships, not have to think about them, not have to carry extras, and know that when you're under fire, the lights aren't going to go out. So we developed lights over a period of a few years that they could put on, and when they're under fire, they don't have to think about their lights. And one of the things that came from that was an investigation into flicker in lighting, because if you're on a submarine or a ship where all of your light is artificial for like 90% of your time, you really don't want your lights to be flickering, either visible flickering or what's called substropic flicker, which is sort of invisible flicker. That was a big issue with fluorescent lighting. And then the drivers, especially with magnetic ballasts, the drivers became quite good at eliminating flicker. And then with the introduction of LED, it was reintroduced. People sort of forgot about it. And so you can go into any facility with LED lighting and use your phone's slow motion setting for video and record it and play it back in slow motion. And you're probably going to see some flicker. Good LED lighting, quality LED lighting won't have flicker, but there are many, many environments where you might not even see it. You record it, and it's like, oh my gosh, that's a lot of flicker. And so we worked to eliminate that for the US Navy. And within that, we actually ended up becoming the first LED lighting that was UL certified flicker free. So below 1%. You can't actually distinguish between 0 and anything below and between 1%. So what we're going to be talking about today is sort of lighting and health. And so as we went into the commercial segment, we brought our same flicker-free products into that. And then in the past year, we introduced what Joe mentioned very briefly, which is color tuning and dimming LED tubes. The benefit of that being ease of installation and while getting all the benefits of quality lighting. Next slide, Cindy. So who are our clients? We do a lot of clients with the education segment, a lot of universities because they care about quality lighting. Healthcare, critical for them. Cleveland Clinic, we work with them on the development of a lot of our products because they have the reputation for health, somewhat obviously. And we love to work with them on products that will be able to be installed in other facilities to get those same benefits. Somewhat obviously, the US Navy is where our heritage is based, so robust 10-year warranty on all of our products, sort of no questions asked. Our failure rate with the US Navy products is less than 0.0002%. So less than one light fails in a million. So that's pretty fun. Next slide, Cindy. So as Joe alluded to, human-centric lighting focuses on the non-visual benefits of lighting typically. It sort of goes beyond that to talk about the physiological and biological benefits of light. So visual benefits, as we all know, being comfortable under your lights, eliminating flicker, eliminating glare, improving task performance, your ability to read the documents that are in front of you is very helpful. And then you go into the non-visual benefits, which includes circadian benefits, which is effectively your sleep-wake cycle. And then the acute benefits, which regulates body temperature, heart rate, alertness, pupil dilation. Those things are usually associated with their circadian system, but there are a few differences. For this presentation, we're going to focus mostly on comfort and your sleep-wake cycle, just because if you can impact those two, everything else sort of comes with it. Next slide, Cindy. So how does HCL, human-centric lighting, boost health? The first thing, and sort of I think the most important thing, is impact on sleep, which is your circadian cycle. Because sleep affects health in every situation, every way. As many know, insufficient sleep is linked to numerous diseases, long-term chronological diseases, and they've been linking insufficient sleep, and insufficient sleep is anything less than 7 hours a night. So a lot of people are getting less sleep than they think they are. So part of that is also with COVID. Sleep has a number of impacts on your immune system. And so making sure that your immune arsenal is fully stocked at all times will keep you healthier, happier. It's super critical. Next slide, Cindy. Now, for spaces, like schools in particular, sleep and lighting that improves your sleep can help improve memory. So several studies have shown that sleep is critical to lock in memories. This basically happens from the hippocampus transferring short-term memories into long-term memories, which is the neocortex. So it's effectively active consolidation systems. So having great lighting can actually help you with both performance and sleep. Those two are really the two focuses that I think are your best benefits. Next slide, Cindy. So what is sort of circadian lighting, which is a subset of human-centric lighting? Basically, you want your lighting as to mimic the natural lighting, so the sun, as close as possible. So as Joe said, lighting that is warmer, so like 2700 Kelvin, is generally associated with calmer moods. So in the evening, having warmer light will help you relax, unwind from the day, and it'll also impact your sleep at night. We'll get into that in a little bit. So during the day, you also want bright, bluer, sort of more daylight colored light to keep you alert and help you stay awake and all of that during the day. Next slide. So how does that all work? And now, not to get too technical here, but there is a couple little important points. So you have 3 photoreceptors in your eye: your rods, your cones, and retinal ganglion cells. Now, why is that important? So your cones are your color sensitive cells. Your rods are sort of light dark, And your retinal ganglion cells, they don't help with vision. They only connect to your suprachiasmatic nucleus, the SCN, to basically entrain your circadian rhythm. But your cones and rods also play a part in that. And why is that important? Well, your cones, as they are color vision, are more light sensitive to certain colors. So as Joe mentioned, where you can dim down certain colors of light and it looks the same brightness, well, a 6500 Kelvin color temperature light is at 100, at like 60% brightness, is going to look the same level of brightness as a 2700 Kelvin color temperature lamp at 80 to 90% brightness. So you can dim it down, you can keep it brighter. It just depends on what you're going for in terms of benefits, whether you want a really brightly illuminated space or to save energy. Now, that's critical because your cones are most light sensitive to the blue light range. Now, if you think back to your biology classes, and effectively we evolved from sea creatures many millions of years ago. So in the sea, because shorter wavelengths pass through water more easily, you end up with bluer wavelengths. So you're actually most sensitive to the 555 nanometer wavelength, and that happens to be blue. So when you have that blue light in the morning or when you go outside, that's actually entraining your body's systems, so your biological systems, to tell you what you're like, when to stay awake and when to go to sleep. That's entraining that. So next slide, Cindy. So what are the 3 conditions to entrain your circadian system? So the first and most important is the timing of light. So if you have bright lights on and during the night, you're probably not going to sleep very well. 1 hour under bright light can be a circadian stimulus. Half an hour under very bright light can be a circadian stimulus. Short periods, like a couple minutes here and there, aren't really going to do very much. But if you're sitting in the office at 8 o'clock and your lights in your office are 6,500 Kelvin, 4,000 Kelvin, sort of normal lights for an office space, you're not going to get as good sleep that night, or you're going to push your circadian rhythm forward. And what that ends up meaning is that if you don't sleep a little bit later that day, you're going to feel really groggy. And then you're sort of pushing your entire cycle forward or back. Just not a good situation. So if you can have high melanopic content light, which is basically high CCT or Kelvin color temperature light during the morning and midday, that's ideal. Then you want low melanopic content light, so low warm light in the evening, and then you want darkness when you're asleep. If you do those 3 things, you're basically fine. You don't need an automated system if you're fine doing that yourself. There are automated systems out there. We have a system that'll enable you to do that fairly easily. We'll get into that a little bit later. The second most important is the intensity of the light, so the brightness of the light. So when you're outside, a sunny day, the way we measure brightness is lux, just for knowledge there. And when you go outside on a sunny day, you're anywhere between 20,000 lux and 100,000 lux. On a cloudy or rainy day, anywhere from 2,000 lux to 10,000 lux. So you're never really below 2,000 lux ever outside during the day. Now, in an office space or in really any interior space in your home, your office, store, grocery store, shops, you're generally between 200 and 800 lux. So you really need to get outside for a short period of time, at least half an hour, if you really want to entrain your circadian system, or make your lights very bright. Typically, it's easier to get outside. Now, the third, sort of almost thinking of the first 2 as sort of sledgehammers for how to set your circadian rhythm. The third of color temperature is sort of that rubber mallet to fine tune it. So if you want to keep your lights the same level of brightness throughout the day, thinking like an office space, you want to be able to shift that color temperature to tell your body what time of day it is. If you start your day and go through the middle of the day with a high color temperature light, and then end your day with a warmer sort of 2700 Kelvin, your body will say, okay, it's time for sleep. Now, I talk about this, but how does that actually work? Next slide, Cindy. So your body produces two hormones that really regulate your sleep-wake cycle. Those are melatonin and cortisol. So cortisol is that same hormone that you're thinking of that is your stress hormone. It's your fight or flight response. Melatonin is that hormone that helps regulate, tells your body it's time to go to sleep. They are inverse cycles. So you don't want those coming closer together or farther apart. You want them to stay sort of where they are. If you do that, you'll wake up energized and you'll go to sleep very easily. And being able to sort of suppress melatonin during the day is usually the measurement of circadian or human-centric light. And being able to keep that entrained in a similar pattern is the key here. Next slide, Cindy. Now, this slide is a bit uncomfortable to look at, and that's on purpose. So visual comfort is critical when it comes to working in your spaces and living in your spaces. And since the human brain processes entire images roughly every 13 milliseconds, you're processing more images than you think. And this optical illusion is there to demonstrate that you're actually seeing things, your brain is processing things differently than what things actually are. So when you're talking about something like flicker, you might not notice that you're under it. But if you get those headaches or migraines during the day, that like sort of midday, you're sitting there and you're like, oh, my head really hurts, you probably have flicker in your lighting. And you can eliminate that fairly easily. If you're still have fluorescent, I'd recommend going to LED and getting something flicker-free. But you can also probably just replace the ballast with a higher quality ballast. It's going to be roughly the same cost to actually retrofit it to LED, so probably not the way to do it, but you can do it, and it should eliminate the flicker. So that's one side of it. The second is glare. Quality lighting and placing your lighting in proper spaces, places, will help you reduce your glare. Let's get out of this slide before people get distracted by that. So, end focus. This is our LED lighting control platform that we alluded to earlier. Effectively, LED tubes Type B, being able to direct wire it. So you just put that into your existing lighting spaces that have fluorescent already. You put our wall switch into the existing switch. And now you have color tuning, so 2700 Kelvin to 6500 Kelvin color tuning, and dimming down to 10%. Now, what's sort of special about that? It's really the cost. Before, you'd have to either run 0 to 10 volt wires to be able to get dimming capabilities in your lighting, or wireless system, it's also an option. But with this, you don't have to. Our engineers were pretty clever when they came up with a proprietary communication system that basically eliminates the distortion on the line. When you dim your lights, you probably have it in your bathroom or in other places of your house. When you push that dimmer and you hear that hum from the lights, that's introducing flicker to the line, because you're basically chopping up the current going to the lights. Now, what we were able to do is effectively reduce that current disruption so that you don't introduce flicker throughout the dimming range. So you can dim it down to 10%, 50%, 40%, whatever you want to dim it to. And it's going to be the same quality of light, same efficiency. So you're actually getting that true energy savings, which you wouldn't necessarily in all other dimming systems, which is a big benefit. And you're doing it at a cost that you don't need to replace the entire fixture. There's no commissioning involved. You can just replace the lamps, replace the switches, and you're good to go. So now just next slide, Cindy. Just to give you an example of what that actually sort of looks like. That far left side and that far right side are extremes. You don't really want that in your space, the amber and the blue. What you're looking at is that middle range. So the 2700, so between 2000 and 3000, and going up to 7000. That's that range that you're probably looking for in your office space or your home, and that's what our system enables you to get. Next slide. just sort of quickly on that, because it's not wireless, it's network safe. That's a big feature for a lot of schools that we work with. They don't want something that's hackable. Being able to retrofit it without having to do new wiring saves money, saves time, and without introducing distortion to the line. So you get the maximum efficiency, no flicker, everything else. And sort of from my background, the sustainability side, replacing lamps or tubes with tubes is so much more efficient, and you're able to upgrade it later in the future. So in 5-10 years, when you want to upgrade to the next and best thing, you can do that without having to go in and replace an entire luminaire like you see in a lot of places. They're very pretty, but you can just replace a troffer if you want the upgraded aesthetic. And you can keep that low maintenance system, and you're still going to get the same life expectancy from tubes as high quality luminaires. So just long-term benefits there. Next slide, Cindy. So just a very quick recap. For healthy lighting, circadian lighting, human-centric lighting, what you want to focus on timing. So avoiding bright blue light in the evening and spending at least 30 minutes outside in the morning. Morning being anywhere up to noon just helps to entrain your circadian system. If you can do it at the same time each day, that's definitely helpful. Less important than just getting outside, but still important. Brightness, keeping it brightest in the morning, early afternoon, dimming it down towards the evening. So that night shift on your iPads, your computers, your phones, that's great. But if you have that at 100% brightness, you're not doing yourself any favors, because Apple and Android, they like to keep their colors not looking completely yellow. So they do keep some blues in there. You're about an hour of sort of looking at a screen, even with night shift at full brightness, is the same as sitting in a room with the lights on. If you can dim that down to 50%, you're going to be doing yourself a lot of favors. Lastly, color temperature, keeping it higher, bluer in the midday time or morning, and lower, sort of yellower in the evening, definitely helpful. I'm going to shift it over to Jim, and he's going to talk about our UV stuff.
All right, thank you, Chris. Well done. Everything that Chris has talked about has been put through with technology that is communicating over the power lines, the electrical lines. So we don't run additional wiring. We don't use wireless networks. We don't use Bluetooth. We communicate over the power line. So all you're doing is replacing the switch in the tubes in your lights, and now you have the lighting control systems, which Joe spent a lot of good time talking about. We've come up with a simple solution to that. And with what happened with the world back in March when the COVID, when everyone basically got pandemicked, we came out with discovering UV light and how it can attack the germicidal irradiation. Next slide, please. So we've come up with a way to communicate with anything, which is over the power line with patented technology, and our 2x4 above troffers, and we're going to have the 2x2 also, is designed to filter the air in the room while there are people in the room, so that you can do the germicidal irradiation and kill and reintroduce clean air back into the same room. The stats here are simply put, one of those systems is designed for about 2 air changes every hour, and with the UV lighting, we're destroying. So it's very similar to what they talked about earlier. Next slide, please. We're all familiar with the troffer, and the design is quite simple. The key is what you're seeing when you see the tubes in this troffer. Those are in focus lights, or could be LED tubing, or I don't know that it wouldn't be compatible with fluorescent because we've already eliminated the ballast. So with the end focus platform, you can communicate with your lighting, and we also have introduced the filtration system, which is the fan and then the air so that you get those air changes. It's a standard, simple system. This is price point comparable, much cheaper than what's out there on the market now. This isn't the first out there, but it's going to be something that you're going to start seeing at all of the hospital waiting rooms, doctor's offices, retail stores, schools. we're trying to make it so that it's very inexpensive to install so that everyone can have this. We all agree the world has changed, and we're trying to make it so that everyone is safe and can start being back out and function as normal. So next slide. The 2x2 fits in the same trough or space as you would, and it's designed for slightly less airflow, but we're still trying to get the 2 air changes per hour. So you may need multiple of these. It's just to be able to integrate into a retrofit, which is the key to the simple installation so that we can all have better, safer environments. Next slide, I think we're wrapping up. There you go. So our presentation on the UV was not real detailed at this moment because it's, as you know, there's a lot of discovery and release. We can answer questions after we go. So put the last slide up, Cindy, and then I'll have our information. And if there's any questions, go ahead and we'll see how we go. So thank you, everyone.
Chris and Jim, thanks so very much. Great presentation. Isabella, I'm going to turn it over to you. Do we have questions for them?
Yep, I've got a few. Existing ballasts and wiring have to be removed to retrofit with energy-focused LED lamps, right?
Yes, basically you have the type A, type B, and type C style. The type B is bypass the ballast, and the N-Focus platform, which is the color tuning and the dimmable, is bypass the ballast. So you can leave the ballast up in the ceiling and just cut the wires from it. It's something that I can show somebody so simply to do that it's a simple process.
How much does it cost to outfit an office with the energy-focused color tuning and dimming? Also, I'm confused. Do you add the color tuning to a regular LED?
Well, let's start with the second part of that question. The color tuning, the LED lamp has the ability to change the color and dim down within the same lamp. The driver for all of our LEDs is in the lamp. So if you ever had an LED 4-foot or 2-foot tube and you took it apart, you'll pull it apart and you'll find the drivers inside. Basically, it's a printed circuit board with a lot of components on it. The reason that the energy focus product line is used exclusively by the US Navy is because of the technology that goes into there. Everyone knows printed circuit boards are basically computers. Computers need software to operate. We have proprietary software and components on the driver, which is part of the integration of the LED tube. So you replace the LED tube in your fixture, you bypass the ballast, and at that point, if you want to have the color tuning and dimming, you go with the N-Focus platform and you simply replace the switch that's on the wall that controls the troughers. So the first part of the question, basically you could look at energy or lighting controls, and we're about 1/3 to 1/4 the cost of lighting control systems as they are today. The high-end network systems, they can really, if you don't have somebody like Joe on your side, you're going to need an IT expert to figure all that out. Our system is, we like to say, it's a tube and a switch. You don't have to have an IT person run additional wiring or do any programming or controls. If you can replace a switch on a wall and bypass a ballast and stick a tube in a trougher, you complete the installation. Approximately about $400 is what you're looking at to spend for an average size office. We're a conference room size. So it's low cost and you don't have to do the whole building. You can pick and choose the buildings or the rooms that you'd like to do the retrofit with the N-Focus platform.
Is any other equipment, perhaps a fan, needed to facilitate full treatment of room air?
Ideally, you want to, I'm assuming this is the UV COVID attacking question. So ideally, you want fresh air and to move air in a room. So we have the trougher in the ceiling, and you can do the UV system in your HVAC. And we also have another system, which is we're calling a portable unit, which would set in the corner of a room, and it's going to move some air and move air around and also intake air from the floor level, where it's going to pass through a UV lamp there also. So really the strategy of defeating COVID and all other airborne diseases like this is going to be to move air and use as much UV as you can, which is not visible to the human eye because it's in chambers and different compartments. But yes, you'd like to move air around.
What does this retrofit with UV lighting do as to the prior discussions on lighting, color, and circadian rhythms?
It's separate from the lighting, color, and circadian rhythm. It's integrated in to move air across UV, which we know destroys the bonds which prevent the spread of the coronavirus and such. So it's not related to the circadian rhythm of the N-Focus platform. So you will not see the UV lights in the room. You would have the N-Focus lighting systems in your ceiling. You would see that lighting. The UV light is not something you're going to have visible to you. It's up above the troffer in a contained chamber where the air is circulated through.
Is the system DLC listed? If not, are there plans to get it DLC listed?
The N-Focus platform is, well, the standard process for all new products to the market is UL listing, and then once UL is complete, which we're completed, is DLC. So the next process is the DLC, and yes, we are in the process right now of doing that. So
I would expect in the next couple of weeks, essentially.
There you go.
All right, those are all the questions I have. If anyone has any more, please drop them in the chat box.
Sounds good. Thank you. It's a great morning.
We'll give just another minute or two for some final questions for any of our speakers. But let me take this time again to thank all of our speakers. Those were wonderful presentations. We appreciate your time. We appreciate you participating with us today. And again, remember, we'll be sending out a very, very short survey on today's session. Let us know how we did with comments for any ideas for future sessions. And then towards the end of the month, you'll be getting a more robust survey asking you how you would feel about quite a number of different topics for 2021. I encourage you to fill out that survey because without your input, we really we really don't know what you want to hear about. So we appreciate your input and help us determine what the best sessions will be for next year. Any other questions, Isabella?
I don't have any.
Okay, well then I think we'll quit a little bit early today. Again, thanks everyone and hope to see you at the November session. Take care.
Thank you, Cindy. You too.
Bye-bye, everybody.
Thanks, everyone.
Thanks all.
Good job, Ron. Good job, Joe.